so here we go. The equation for this is, which you also need to memorize, is N equals C. 0.5 T divided by H. This looks a lot like the pain formula, which it is. C is going to be the starting mass. M is going to be the ending mass. T is going to be time. And H is going to be the length of one half-life. Okay, so this will be our second equation. Yeah, go ahead.
T over H.
T divided by H as a fraction. Yeah. So there's a fractional exponent, which also we talked about this here as well too. Okay. This question is calculator heavy. Okay. We're going to do a table to make sure it makes sense here. Okay. But this is calculator heavy. This is our second big equation we need for this unit. There will be two more in the next 2 days. Yes. Okay. Here we go. Example 1 says. I'm going to fix these examples because this is something I'm not going to do anymore. Here we go. Caffeine has a half-life of 4 hours. If Mr. Sadler drinks 12 grams of caffeine, how much do I have after 9 hours?
Don't you measure drinks in ounces?
No. I don't mind grams. I'm just joking. It's a math question. Now, this is old because I don't drink as much coffee anymore, okay? But 12 grams of caffeine would be like a few cups of coffee, okay? The reason caffeine has a half-life of 4 hours is that if you think, if people will have, generally, they might have a cup of coffee for breakfast, can of pop with lunch, cup of tea with supper, right? And then their caffeine levels are high through the whole day, okay? That's what generally happens for people, okay? All right, so I'm going to start off by making a chart so to make sure we understand what's going to happen here, okay? So here's my chart. This is an optional chart, but I will do it for every example. Okay, I'm going to make the time and the mass chart. At time 0, how much caffeine does Mr. Sadler have in his system? Oh, and I'm going to pick on you.
At time 0, we have no caffeine.
Nope, close. 12 and a half. That's our starting value. All right, Adria, what's our next time going to be? What's that? Okay. Right, because every half-life is going to be 4 hours. It's going to be 4. How much mass is going to be left after 4 hours? 6, right? We're just going to divide it by 6. Because we said, yeah, the half-life here is 4 hours. After 8 hours, how much mass is going to be left? Great. After 12 hours, how much mass is going to be left? 1.5, because we're just dividing by 2, right? So then when we said 0, it's never going to be 0. And yeah, the reason I can stop at 12 is because I'm actually looking for 9 hours, which is going to be in here someplace. Okay? So with my guess, I'm guessing that after 9 hours, I'll be like 2.5 grams caffeine or something like that. So you see the logic I'm using there? The chart is just sort of to verify, because this question is horribly calculator heavy. Okay, so this is just sort of see if you're in the right spot. Okay. So here we go. I'll write my equation on the board, which is M equals C. 0.5 T divided by H. Luke, I'd like you to fill in one of those 4 pieces of information for me, please.
H is 4.
H is 4. That's how long a half-life is. Very good. Noah, can you be brave, please, and fill in one of those 3? C is 12. That's your starting value. Very good. Yeah, go ahead. T is 9. Good. times going to be in there. Yeah. Decimal would be possible, yeah. You could, if you want to, you can change decimal. Yeah. Okay, but these will all be whole numbers for right now. Carly, can you sub the numbers in my equation, please? Tell me if right. All right. I would like everyone to try and come up with an answer. Now, as you're doing your answer, remember that it has to be between 1.5 and 3. That's the answer has to be, because that's what my chart says. Okay, so take a second, get your calculators out. Okay, does anyone need to borrow a calculator? Anyone else? Okay, struggle a little bit here and try and get the answer. If you get an answer like 300, your weight's off. Okay, hold on a sec. Hold on. Just keep as many decimals. On my paper, I have, where are we here? I use 2 decimals, that's what I use. Okay, that's fine. 8's even better. 8's even better. All right.
Oh, how many did you do?
I did 2 on mine, but you did it. No, I'm not coming closer. I can't get back there. On break?
I just want to ask you.
Tomorrow, we're doing regular savings. So another complicated equation, another equation. It's big, but that's all.
So, if you had,
We had next week.
T, or like,
Sun's red.
like if you change any one
Except for has been out since reading.
double,
Okay, so let's go through here. The answer should be 2.52. Now, how you should have gotten that, if you have an old-fashioned calculator like me, is I did this. I did 0.5 to the power, bracket, 9 divided by 4, bracket equals, and then times 12, and then equals. That's on my old-fashioned calculator. If you have a super-duper calculator, like Carissa, she should be able to do that all in one step on her calculator, no problem. She's saying maybe not, all right? Okay. Okay. Was anyone able to get 2.52? You got it? You got it? Anyone unable to? Unable. You guys are all lying to me. That's okay. Tristan, you got it? You did not. You're good?
I know.
Are you close? Okay, good. One person is honest, okay?
Oh, sorry.
Wrong. All right, here we go. Okay, here we go. Example 2.
Do you know where they lost? You were watching that, guys.
Hey guys, let's go here, please. Okay. I'm going to say the mass of carbon in a substance. Got it. Originally was 0.8 kilograms. And the current value is 0.03 kilograms. If carbon's half-life is 15,000 years, how old is the specimen? Okay, but seriously, somebody go ask.